Welcome to Learning with Philemon. In this video, we will be looking at the organic compounds called alkenes. Alkenes, like alkanes, are a type of hydrocarbon, compounds containing only carbon and hydrogen atoms. Unlike alkanes, alkenes contain one carbon-carbon double bond. The first possible alkene is ethene, C2H4. You cannot have an alkene with one carbon because that carbon is not able to form a double bond with another carbon atom. The stem, beginning of the name eth, indicates that the longest chain contains two carbons. The suffix -ene indicates that there is a double bond present. Here we can see the longer alkenes, propene and butene. Remember that carbon can only form 4 bonds. This is why the carbons involved in the double bond are bonded to less hydrogen atoms. For more on this, watch the covalent bonding video. The general formula for alkenes is CnH2n. If you have 3 carbons like in propene, you have 6 hydrogens. Remember that the general formula of alkanes is CnH2n plus 2. Alkanes contain more hydrogen atoms than alkenes. Alkenes belong to a class of compounds called unsaturated. Unsaturated compounds do not contain the maximum amount of hydrogen atoms possible per carbon atom. This is because of the double bond they contain. Alkanes are saturated compounds. They contain the maximum number of hydrogen atoms possible per carbon atom. Now let's take a look at how alkenes are formed. In the fuels video, we saw that crude oil is a mixture of alkanes. These alkanes can be separated using a process called fractional distillation. Longer chain alkanes that are not useful can be broken down into shorter chain alkanes and alkenes. This process is called cracking. There are various ways to conduct this reaction. In catalytic cracking, a high temperature, approximately 550 degrees Celsius, and a zeolite catalyst that consists of aluminium and silicon oxide are used. An example reaction is shown below. Hexane, C6H14, is broken down to butane, C4H10, an alkane, and ethene, C2H4, an alkene. Note that in cracking, an alkane and an alkene are always formed. This process is important because fractional distillation often produces more long-chain hydrocarbons than are needed by consumers. Using cracking, shorter chain alkanes are formed that are in greater demand as fuels. Alkenes can be used to form other products such as alcohols and plastics. Now let's take a look at what reactions alkenes undergo. Alkenes are more reactive than alkanes. This is due to the double bond between the carbon atoms. For more on this, please watch the IB level videos. Alkenes undergo combustion reactions like alkanes. In this example, propene, C3H6, reacts with oxygen to form carbon dioxide, CO2, and water, H2O. For more on combustion reactions, watch the alkanes video. Alkenes also undergo addition reactions. In addition reactions, 2 molecules react to form one product. For example, ethene reacts with bromine gas, or aqueous bromine, to form dibromoethane, C2H4Br2. As can be seen in the structural formulae, the double bond between the carbon atom breaks. Each carbon atom is then able to form a single bond with a bromine atom. For more on how this mechanism works, please watch the IB higher level video, Electrophilic Addition. Adding a halogen to an alkene will always lead to the production of a halogenoalkane, in this case dibromoethane. This is a very common test that can be done in the lab to distinguish between alkanes and alkenes. An aqueous bromine solution has an orange-brown color. When added to an alkane, there is no reaction and the solution retains its color. Remember that alkanes react with halogen only in the presence of UV light. When added to an alkene, there is a reaction and the solution is decolorized, turns colorless. On the left-hand side of the image, we see an alkane added to bromine water. The alkane does not react with the bromine, so the color is retained. The alkene and the bromine solution do not mix, so two layers are formed. Alkanes have a lower density than water, so float above water. On the right-hand side, we see an alkene added to bromine water. The alkene does react, so the bromine solution is decolorized. The bottom layer now consists of just water. The upper layer consists of the halogenoalkene formed. Now let's take a look at other addition reactions alkenes undergo. Alkenes can also react with hydrogen gas in the presence of a nickel catalyst. For example, ethene reacts with hydrogen gas, H2, to form ethane, C2H6. The carbon-carbon double bond breaks, yet again, and each carbon can form a single bond with a hydrogen atom. In this type of a reaction, an alkene is converted to an alkane, in this case ethane. Alkanes can also react with steam at high temperatures of approximately 300 degrees Celsius in the presence of an acid catalyst. For example, ethene reacts with steam, water vapor, H2O, to form ethanol, C2H5OH. The carbon-carbon double bond breaks yet again. This time one carbon atom forms a single bond with a hydrogen atom, and the other carbon atom forms a single bond with a hydroxide OH group. In this reaction, an alkene is converted to an alcohol, in this case ethanol. Alcohols are a different type of organic compound that will be discussed in a later video. In summary, alkenes are unsaturated hydrocarbons that contain a carbon-carbon double bond. Alkenes are formed from cracking of longer chain alkanes. Alkenes undergo combustion and addition reactions. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.